Hi, this is Lindy Jilali. This presentation is all about properties of ellipse. Welcome to the presentation. So we all are familiar with different type of coordination. Our interest is to discuss something about ellipse. So equation of any conic in polar coordinate system is given by r is equal to r naught divided by 1 minus epsilon cos theta. When we do coordinate transformation, so we coordinate transformation means these are coordinate transformation equation. We substitute it here, we will get the same equation in Cartesian coordinate. If these equations are substituted, we will get Cartesian coordinate equation in Cartesian coordinate. So this is the equation of any conic in Cartesian coordinate system: 1 minus epsilon all square x square minus 2 r naught x plus y square is equal to r naught square. So ellipse is a special case in which the value of eccentricity lies between 0 and 1. So now we will see something about ellipse. So first of all, let us plot how it will look like. So we see that this ellipse is symmetric about x-axis, but its center does not lie at origin. So center of ellipse is somewhere here and origin is of the axis and it is not coinciding. Now we see some important dimensions in this ellipse. First, let us start with semi-major axis. So if from the focus to one of the point of the ellipse, it is r, the angle made by r, let it be theta. So we see what is the length of semi-major axis. So in order to calculate the length of semi-major axis, first we want to calculate the length of major axis and we want to divide it by 2. We will get the length of semi-major axis. Now, when theta is equal to 0, the length of this radius will be the maximum value that can be achieved in an ellipse, that is r maximum. So we want to know r maximum. We want to substitute the value of theta here. That means cos 0, it is nothing but 1. So r maximum will be r0 divided by 1 minus epsilon. So in order to find the minimum value of radius, that is somewhere here, this theta should be 180 degree. That is nothing but pi. When we substitute value of pi in cos theta, we will get that is minus 1 here. We will get r minimum is equal to r naught divided by 1 plus epsilon. So the length of major axis will be the sum of r minimum and r maximum. So when we substitute those values, and on simplification or taking r outside and on simplification, we will get the value of major axis, that is 2r naught divided by 1 minus epsilon square. If we know the major axis, the semi-major axis will be the half of this quantity. That means r naught divided by 1 minus epsilon square. Now we want to calculate the distance from the origin to the center of the ellipse. So this is, let it be the center of the ellipse. So this distance is what we need to calculate now. Already we know what is major axis and thereby semi-major axis. We know what is the value of r minimum. If so, x naught will be a minus r minimum. We know what is a and we know what is r minimum. We substitute that and on simplification we will get x0 is equal to r naught epsilon divided by 1 minus epsilon square. But this value is a, the semi-major axis. So we can write it like this way. That means the eccentricity is the ratio of x naught and semi-major axis. Now, for an ellipse, we know what is major axis and semi-major axis. Now we want to know what is this is. If this is the minor axis, half of it will be the semi-minor axis. Now what we are going to do is we will calculate what is the value of semi-minor axis. Now we know what is x naught. This will be the radius from at any point, and the focus line made by it will be the radius that we know. Let theta be the angle made by r and x naught. From Pythagoras, using Pythagoras theorem, we can simply say the value of b is equal to root of r square, that is hypotenuse square, minus h naught square. We know what is x naught, but with respect to different theta, the r value is changing. So we want to calculate this value of r, and we want to substitute here to calculate the value of semi-minor axis. So we will start with the equation of conic. In this cos theta, that is with this particular value of radius, this angle made by this particular radius is theta, and with this theta, the cos theta is given by x naught by r. We know cos theta is equal to adjacent side by hypotenuse. We will substitute for h naught by r in the place of cos theta, and on simplification we will get r is equal to r naught plus epsilon x naught, and we know what is x0. We already calculated it. We substitute that, and on simplification we will take r naught outside, and on simplification we will get r is equal to r naught into 1 by 1 minus epsilon square, that is r naught divided by 1 minus epsilon square. Now this value of r is used here to calculate, and on substituting the value of r and x naught we already know, when on substituting those values here, and on simplification we will get the value of the length of semi-minor axis as r naught divided by root of 1 minus epsilon square. Another interesting thing in this particular case of the ellipse is we are going to prove is origin of the axis lies at one of the foci of the ellipse. This is what we want to calculate. But we know one thing. According to the definition of ellipse, the sum of the distance from the foci to point on ellipse is a constant. That is, sum of the distance from the point from the foci to a point. Say this is a point. Then sum of these two lengths will be a constant. If we consider any another point, sum of these two lengths will be a constant, the same length. If we consider another length, the sum of these two will be again that constant. Same, this length and this length, if we add, that will be the same value obtained with any another points. Now, if the origin for this case, or if the origin is at this focus, now in order to prove that origin is at one of the focus, we need to say that the sum of this length and this length, that is any two radius made by two focus, is constant. That is, say this is r, and radius made by this focus, let it be r dash. The sum of r and r dash is equal to a constant value. If this is proved, we can say that origin is at a focus. Now, very easily we can understand that the law of cosine say r dash square is equal to r square plus 4x naught square minus 4r h naught cos theta. From the equation of conic, we can write r cos theta is equal to r so we will substitute for r cos theta here in this equation. so that the law of cosine is changed like this way. That is r dash square is equal to r square plus 4x naught square minus 4r x naught divided by epsilon plus 4 r naught x naught divided by epsilon. Now in this expression, we know what is the value of x naught, and we will substitute here, and on simplification we will get a wonderful expression in which the right hand side is a perfect square. Therefore the value of r dash will be plus or minus r minus 2r naught divided by 1 minus epsilon square. This is nothing but major axis, that is r dash is equal to plus or minus r minus major axis. But we know every time the major axis will be greater than the value of radius. That is well known. But here the plus value or minus value, this is either positive this thing or negative value of r minus a will be there. So we must choose the a value such that r dash is not it's greater than 0. So we will take the minus term here. Hence r dash plus r is equal to a, which is a constant. So we proved origin is at the focus of ellipse. So we see certain standard results in ellipse. Now let us go back to inverse square force problem, that is nothing but planetary motion. Let us go to the planetary satellite orbit. We already discussed about satellite orbit. So in the planetary motion problem, we know what is r0 and eccentricity values. So now we are very much clear about some fundamental values in the ellipse. So what we are going to do is we are concluding by listing our this term with including energy, angular momentum, point mass, constancy, etc. So if we know what is the semi-major axis, it is r naught divided by 1 minus epsilon square. So instead of r naught and epsilon, we will substitute these values. So we will get minus c by 2e. On simplification, we will get this, and this is an expected result. Similarly, for semi-minor axis, b is equal to r naught divided by root of 1 minus epsilon square. We find out. So instead of r naught and epsilon, we substitute our known values. We will get 1 by root of minus 2 mu epsilon. Similarly, x naught also we can calculate. X naught is r naught epsilon divided by 1 minus epsilon square. So if we substitute and simplify, we will get this quantity, and that is c by minus 2e into root of 1 plus 2 energy length energy angular momentum square divided by mu into c square. So this is all about ellipse and its properties. Thank you.